All right, this is a next video in our work on solving quadratic equations, and in this particular video we are going to use factoring to solve them. And we're going to start off with a introduction and then do a few solved examples. All right, so first off we need to do a quick reminder on factoring trinomials. Okay, we've done it before, but I want to remind you of how we can do it. And the first thing to always have in your mind when factoring is to think about the GCF. Okay, is there a GCF we can pull out front that we can factor out that'll make our factoring job a whole lot easier? And in this case there's a GCF of 2, so I'm going to pull that GCF out front to get a 2x squared minus 5x minus 3. Okay, and then our goal is to really turn that trinomial into the product of two binomials. Okay, and there are a couple ways to do it. We could do some guessing and checking and see what works, and I'm going to model that here. I'm doing this live. I don't have this answer memorized. I'm going to see if I can get it right. Is this a minus? Factors of -3 are -3 and +1, so that turns into a minus 6x plus 1x is minus 5x. So we got it. And alternatively, I want to remind you, so that's our answer. But alternatively, I want to remind you of what I call the AC method. So I'll refresh that in your mind as well. We can first off rewrite our problem that we're trying to solve. A times C is -6, and then we need to find factors of -6 that add to our B value of -5. And so that would be -6 and 1. So we will use these numbers, -6 and 1, to split up that middle term. So let's rewrite it. -6x plus 1x minus 3. So again, we're just rewriting our equation, but with the middle term split into two components. And then we find the GCF of each half, the yellow GCF and then the orange GCF, and pull it out front. Let's do that real quick. Looks like we have a GCF of 2x, leaving an x minus 3 behind for the yellow pieces. And then we have a GCF of just 1, meaning there isn't really a GCF, leaving an x minus 3 behind. And then we overlap. These two terms should be the same. We overlap them and then rewrite. And so we have 2, and then in brackets 2x plus 1 times our x minus 3. So we got the same answer as we got above. We went through a little more of an algorithm to get it, a little less guessing and checking, although it does take a little bit longer, okay? So again, my advice on factoring is to try to just guess and check, do it in your head first, like we did up here. And then if you can't get it right away, or if you can't get it pretty efficiently, go through the AC algorithm and you'll end up going through that process. So as a reminder, this is what I call the AC, or A times C method. And back in our polynomials unit, we had a couple videos on that. All right, so that's just a reminder on factoring. The next thing, as part of our introduction, I want to remind you of the zero product property. And maybe not remind you of it, but introduce you to it. And my task that I want you to think of is brainstorm as many as you can, as many pairs of numbers with a product of 0. Okay, and there's a point to this. You might think it's kind of a weird question. How many pairs of numbers can you think of that have a product of 0? Okay, 0 and 0, 2 and 0, 3 and 0, -4 and 0, 0 and 5, 0 and a million. You getting the idea? Every single one of those numbers has a 0 in it. Okay, so this is the zero product property, which says that if two numbers multiply to be 0, one or both of those numbers must be 0. So if the product of two numbers is 0, one or both of those numbers must be 0. There's no other way to do it. Okay, so this is called, again, the zero product property. So if the product of two numbers is 0, at least one of them has got to be 0. Okay, so let's apply that. And so I just asked you to go through that task for a reason. We're going to apply that. And so let's check out what we have here. We have the product of two binomials, which if we FOILed this out would be a quadratic. So remember, we're trying to solve quadratics. And we have the product of two different things, and they're equal to 0. So that means that one of those things, or both, must be 0. Okay, the only way to get a product of two things equal to 0 is if one of those things is 0. So we have two options. One option is x plus 5 equals 0, which means x is negative 5. And that's one of our solutions. The other option is if 3x minus 2 equals 0. We could solve that, add 2 to both sides, divide both sides by 3. That gives our other solution, okay? And here's what's cool about this, which you might not realize. If you plug a negative 5, let's check that. Let's plug a negative 5 back in. We are going to plug it in for both x's, okay? Let's see if it works. So we have a 3 times negative 5 minus 2 times a negative 5 plus 5. And we're wondering, is that equal to 0? 3 times negative 5 minus 2 is negative 17. Negative 5 plus 5 is 0. Is that equal to 0? It is, because negative 17 times 0 is equal to 0. So that first answer of negative 5 checks out, and the 2/3 would check out as well. Okay, so we are applying the zero product property because we have two things that multiply together to give us 0. If we didn't have a 0 here, we couldn't do it. We couldn't do it that method, right? We have to get a 0. We have to get the product of a couple things equal to 0. All right, let's move on. And so now we don't have a product of a couple things equal to 0, but we do have something that we can factor. And so this is what we will be doing a lot in this unit. We'll be trying to factor quadratic expressions, make sure they're equal to 0, and then use the zero product property. Looks like this is going to be x plus 5 and x plus 8. So we have two options, okay? So one option is x plus 8 equals 0, which means x is negative 8. And our other option is x plus 5 equals 0, which means x is negative 5. Okay, so those are our solutions to this particular problem. We couldn't have solved this problem back up here. We couldn't have solved it by subtracting 40 from both sides and then dividing by x or anything, okay? It really is solved best by factoring and then doing the zero product property. And the last one, for this particular video, we don't have it's not called the 6 product property, okay? It's called the zero product property. So we have to get that equal to 0, okay? So let's first just subtract 6 from both sides. So I'm going to get a 4x squared minus 10x minus 6 equals 0. Okay, so now we can work with the zero product property. Remember, always look for a GCF when you're factoring, and so we're going to pull a 2 out front. And this problem might look familiar from the initial warm-up problem we did in this video. What we can even do, though, is we can just divide through by this 2. Get rid of it, okay? When we're just factoring, we needed to keep the 2 there because we didn't have an equal to something that that we could do to both sides, okay? But now we have an equal sign, we have an equation, we can divide both sides by 2. 2x squared minus 5x minus 3 equals 0. So we can factor, and I'm going to peek a little bit what was the result of that factoring way up above. 2x plus 1 and x minus 3. So we have 2x plus 1 times x minus 3 equals 0. Mathematicians do that a lot. They just revert back to a problem they've already solved. Why solve it again, right? We've already done it. So let's just use the result we've already gotten. And so now we have two possible answers. X minus 3 equals 0, which means x is 3. So that's one possible outcome. And 2x plus 1 equals 0, which means 2x equals negative 1, which means x is negative 1/2. So there are our two solutions, x equals negative 1/2 and 3. All right, so we solved those quadratic equations by factoring and using the zero product property. That's a good place to stop.